Hello, class. We're about to start the review for Chapter 7. The review starts on page 410. And so let's get to it. It says, what is the surface area in square centimeters of a cube with each edge of 5 centimeters? Now, what we have to do, we would have to go back to get the formulas for surface area. Now, the formula for surface area is actually on page 402 and 404. So on 402, we have the surface area formula for a cube, or as we call it, a square prism. And the surface area is equal to 6 times side squared. So we have surface area is equal to 6. They tell us here the side is 5, and that's to the second power. So the surface area is 6 times 25, and the surface area is 150 square centimeters, which happens to be D. Now we go on to problem number 2. Problem number 2, it says, what is the surface area in square centimeters of a cylinder with a height of 10 centimeters and a radius of 6 centimeters? Now, the surface area of a cylinder is this formula here, and is located on page 404. The surface area is 2 times pi times the radius times height plus 2 times pi radius squared. Now, if you notice here with these answers, they have pi in the answer. So what you would have to do, we would not make pi 3.14. We will leave pi in the answer. So we have surface area is equal to 2 times pi. We're told that the radius is 6 and the height is 10. So we add 2 pi times 6 squared. So we have the surface area is equal to 2 times 6 is 12 times 10 is 120. So this would be 120 pi plus 6 to the second power is 36 times 2 is 72. So it'd be 120 pi plus 100 plus 72 pi. So your surface area would be 192 pi. And then that would be square centimeters. And so here that would be C. So now we move on to problem number 3. It says, what is the surface area in square centimeters of a cylinder that measures 8 centimeters tall with the diameter of 6 centimeters on its base? Now in problem number 2, we already did the surface area of a cylinder. And we noticed that it calls for a radius in the formula. So we would know that this diameter will be cut in half because radius is half the diameter. So your radius would be 3. So we would take that surface area formula, 2 pi radius times the height plus 2 pi radius squared. So your surface area is 2 times pi. The radius would be 3, and the height is 8. So we add 2 pi times 3 squared. So your surface area is equal to 2 times 3 is 6 times 8 is 48. So it'd be 48 pi plus 3 squared is 9 times 2 is 18, and that's pi. 48 pi plus 18 pi will give us 66 pi, and then this is centimeter squared. And that would give us C. Now, we will now jump to problem number 6. Now, with problem number 6, they said the floor of a walk-in closet measures 7 feet by 4 feet. If the ceiling height is 8 feet, what is the volume in cubic feet of the closet? Now, we know a closet is in the shape of a rectangular prism. So that'll be length times width times height. So the volume is equal to the length is 7, the width is 4, and the height is 8. So we had a volume is equal to, now we have multiplied 7 times 4 is 28. Then we add 28 times 8. 8 times 8 is 64. We carry our 6. 8 times 2 is 16. Plus 6 is 22. So our answer here would be 224, and it'll be 224, let me see, cubic feet, and that would be D. So that took care of problem number 6. Now we're going to look at problem number 7. It says an ice cream cone has a spherical scoop of ice cream placed inside. Exactly 1/2 of the ice cream is visible above the rim of the cone. What is the surface area of the entire ice cream treat in units squared? Okay, so first of all, we have the surface area of the cone, which would be pi times radius times the slanted height. So that would give us the surface area of pi times the radius. We see the radius 3, and then the slanted height is 10. So this right here would be 30 pi. Okay, now that took care of the surface area of the cone. Now we need the surface area of a sphere. Okay, so the surface area of a sphere is 4 pi radius squared. So we have 4 times pi, and we know that the radius is 3, and that's squared. So we have 4 times pi times 9, which will give us 36 pi. Now, we would actually add these two together, but there's a little extra thing they put in this problem here. They told us that exactly 1/2 of the ice cream is visible. Now remember, we're doing surface area, not just volume. So we're doing surface area. So that means we have to take half of this, because remember, only half of the cone is showing for the, half of the ice cream is showing for your surface area. So we'll take the 36 pi and divide it by 2, and that would give us 18 pi. So this would tell us the surface area of half of the ice cream scoop. So now we would do the surface area of the whole figure by adding these two together. So this would give us 48 pi. That would be our surface area, and then our answer here would be C. So that took care of problem number 7. Now we move on to problem number 8. It says the radius of sphere A is 2, and the radius of sphere B is 1. What is the ratio of the volume of sphere A to that of sphere B? So now we have to have the volume. Okay, so we have sphere A, which is the volume of sphere A is 4/3 times pi radius squared. Oh, I'm sorry, pi radius cubed. And then sphere B, the volume is 4/3 times pi radius cubed. Now we will substitute this. So we have 4/3 times pi times the radius. Okay, the radius of sphere A is 2. So it'd be 2 cubed. So now for the volume of sphere B, we have 4/3 pi, and then the radius here is 1. So now we have 4/3 pi, we'll do 3.14, and then 2 to the 3rd power is 8. Then we have a volume of 4/3 times pi times 1 to the 3rd power is 1. So now we have a volume is equal to, we can have 32/3 times 3.14, and the volume is equal to 4/3. Well, I should have changed this pi to 3.14, and I'll do that here. So it'd be 4/3 times 3.14. Now we would take our calculator. You all know how to put a fraction in the calculator. So I'm going to use this other calculator here. So let me go ahead and use this. So we will have 32/3. Now you know you will press your N over D key. So this is 32/3 times 3.14. And that would give me approximately 33, say 33.49 approximately. Now we'll do the volume of the second one. We have 4/3 times 3.14. So that'll be approximately 4.19. But now they ask us to do a ratio. So we want to do a ratio of these two. So we would do 33.49 divided by 4.19. Now, when we do this, let me clear this out here. So our ratio, if we look here, this would give us, let's do 33.49 divided by 4.19. Now, if you notice here, this is very close to 8. So we would do, this is, when you divide this out, is this value divided by 1. So that would give us C. So it'd be 8 to 1, which would be C. All right, so now we move on. Now we're going to move on to problem number 10. Okay, with problem number 10, it says here, 3 identical rectangular boxes are stacked one on top of another. The total height of all 3 boxes is the same as the width of one box. The length of the boxes is 18 inches. So we have our length is 18 inches. Okay, and the width is half the length. So the width is half the length, which will give us 9 inches. Now remember, the height, we're told here that the height of all 3 boxes is the same as the width of one box. So this means this will be 9 inches as well. So now we're asked here, what is the combined volume in cubic inches of all 3 boxes? So we know this volume is of a rectangular prism, which is length times width times height. So the volume is equal to the length is 18, the width is 9, and the height is 9. Okay, so now when we multiply all this together, this will give us 1,458, and that'll be cubic inches. So the volume is 1,458, which would be A. Okay, now we move on. Okay, let's take a look at problem number 11. It says, using a compass, Mike hikes 300 yards due north. Okay, so let's say he's going north now, 300 yards. From that point, he hikes 400 yards due east. If he were to hike directly to the campsite from the point, how many yards would he have to hike? Okay, first of all, let's do this. North, let's just say we're going up north. So now we will go east. So now what we have here, it says that you went 300 yards north, then you went 400 yards east, and then now they want us to know, they want us to go back to the campsite. So that means you will go here. So this forms a right triangle, as you see here. So we're missing this side here, which would be X. So now, we can use the Pythagorean theorem, which is a squared plus b squared equals c squared. So a, we can make 300, and that's squared. B would be 400, and that's squared equals c squared. So this would be, what's that, 90,000 plus, let's see, 160,000 is equal to c squared. 90,000 plus 160,000 would be 250,000 equals c squared. Now we would take the square root of both sides. So now the square root of 250,000 is 500. So 500 is equal to C, which would be B. Or I should say 500, yeah. So that's B. Okay, so now we took care of problem number 11. Now we move on to our next problem. So looking here at problem number 12. It says the rectangular base of a container is 9 inches long and 7 inches wide. By how many cubic inches will the volume of the container increase if you increase the length of the base by 2 inches? Okay, so first of all, we need to do the volume of the regular figure here, length times width times height, the original figure. So this is problem number 12. So we have the volume is equal to the length is 9, the width is 7, and the height is 12. So the volume is equal to 756 cubic inches. Okay, that took care of the original volume. Now we do the volume here where we increase the length by 2 inches. So the length is 9 inches, so this will be length times width times height. And then the length will be 11 because the length is originally 9. The width will stay 7, and then the height would still be 12. Because that was the only thing that was changed. So that will give us 924 cubic inches. Now we want to find the difference, so we will subtract the 924 minus 756, and that will give us 168 cubic inches. 168 cubic inches is C. So that is the difference. Now we move on. All right, so number 13, it says in a right triangle, the hypotenuse measure is 15 inches. So let's put that down here. So the hypotenuse, or C, is 15 inches. If one leg of the triangle measures 6 inches, we'll make A 6 inches. Which of the following equations could be used to find the length of the other leg? So that'll be B that we don't know. So we got A squared plus B squared equals C squared. So we had A is 6 squared plus B squared equals 15 squared. 6 squared is 36 plus B squared is equal to 15 squared. If I am not mistaken, 15 squared is 225. So we'll subtract 36 on both sides. And B squared is equal to, well, you know what? It looks as though this has this a little different for problem 13. I didn't have to go as far as I did, but if you notice here, if I didn't square the 36, let me go here. This would have actually been B squared is equal to 15 squared minus 6 squared. So if we look at that and we use X instead of B, that would give us D as our answer. So our answer here would be D, because they just want the equation set up. So now we move on to problem 14. It says the length of a rectangle is 3 times its width. So we have the length of the rectangle is 3 times the width. So we'll put 3x, so the width will be x. So the length is 3 times x, which is 3 times its width. So it says if the perimeter of the rectangle is 96 inches, what is the length in inches? So basically what happens is perimeter is equal to 2 times the length plus 2 times the width. So we have the perimeter, we're told, is 96 inches. We don't know what the length is, but we know length is equal to 3x. And then the width is just x. So we had 96 is equal to 6x plus 2x. So we had 96 equals 8x. Now that we had 96 is equal to 8x, we could divide these side by 8, and 12 is equal to x. So 12 is equal to x, which means that A is our answer. So actually, no, I'm sorry. A is what the width is, but they want us to find the length. So we would do the length is equal to 3 times 12, because it's 3 times the amount. So it'll be 36, which would be C. So our answer here should be C. All right. Now, we move on. Here we're going to go to problem 16. It says here, question 16, it says refer to the following figure. It says use your calculator to make the following calculation. The figure above, a square contains a circle such that each of the sides of the square is touching a point on the circle. What is the approximate area in square inches of the shaded portion? So basically, let's take a look here at 16. So we know this is the radius, but we know going all the way down here would be the diameter, which would be one side of this figure. So that means that since the radius is 2, that means the line all the way down is 4. So if this is a square, that means all sides are 4. So what we want to do, we want to do the area of a square, of a rectangle, which is length times width, minus the area of a circle, which is pi radius squared. So the area, length times width, we know that'll be 4 times 4, which is 16. That'll be the area of the rectangle. Now the area of the circle would be pi, and the radius is 2 squared. So this would be 4 pi. So now when we put this in our calculator, we'll take 16 minus 4 pi. So we will find this area of the shaded region by doing 16 minus 4 pi, and we can make pi 3.14. So we will have 16 minus 4 times 3.14. So that would give us approximately 3.44. So the area would be approximately 3.44. Now remember, we're supposed to pick the one best answer. So the best answer here would be A, 3.43. Okay, now we move on. So now we'll skip down to problem 18. 18 says to choose an air conditioning system, the school district must know the volume of the room. What is the volume in cubic feet? So we will read what's up here. A classroom is 40 feet long, 25 feet wide, and the ceiling height is 12 feet. The school district plans to repaint the room and put in air conditioning. The ceiling tile would not be painted. So basically you're doing the volume here for 18, which is length times width times height, because we know rooms are in a rectangular prism. So the volume is equal to 40 for the length, 25 for the width, and then the height is 12. So now when we multiply all that together, that will give us 12,000. And that will be 12,000 cubic feet, and that will give us C. So that took care of problem 18. Now, we're going to go to problem 19. Now, 19 is a little lengthy, but I know we can do it. It says question 19 refers to the following figures. We have these 3 figures here. It says Laura is painting model pyramids for an art project. She needs 1 tube of paint for every 30 square inches of surface area. If Laura paints each pyramid and its base approximately, how many tubes of paint should she buy? So we're going to have to do surface area for all three of these pyramids. So surface area of the first, surface area of the second, and surface area of the third. So this is how I'm doing. This will be the first, the second, and the third. So we'll all be on the same page here. Now we know surface area of a pyramid, and I'll write this off to the side. Surface area of a pyramid is 1/2 times the perimeter times the slant height plus the base. And that's the area of the base. So, and this perimeter is of the base as well. So basically we will have 1/2 times the perimeter of the base. All of the sides are the same, which would be 2. And then the slant height, which would be 3 inches. And then plus the area of the base, which is length times width, which would be 2 times 2. Now that would take care of the first pyramid. The second pyramid, we'll do 1/2, and then the perimeter of the base, which would be all 3s here, add up all 4 sides of the 3s, and then the slant height would be 6, and then plus the area of the base, which would be 3 times 3. And then last but not least, we add 1/2. The perimeter of the base, we add all the 4s. And then the height is 4. And then, of course, the area of the base would be 4 times 4. Now, when we multiply all of this, now the first answer here would be 45. No, I'm sorry. The first answer here would be 16. When you add all these up, take 1/2, this will give you 16. The second value here would be 45, and then the last value would be 48 after you put in these formulas. So you would add all these together. You add 16 plus 45 plus 48, which is 109. Okay, now the problem states that Laura needs 1 tube of paint for every 30 square inches. So this is 109 square inches. So we'll take 109 divided by 30, and that'll give approximately 3.6. Now, so we have to ask ourselves, how many tubes of paint would she need? Now we know we cannot get 0.6 tube of paint. So anything that's after the decimal, you have to go to the next amount of paint. So this would be 4. So she would need 4. She needs 4 tubes. So since she needs 4 tubes, that'll be A. Now just to drive this home, if you ever saw someone that had their house painted, you always notice that they have like a can of paint left, almost probably nearly a full can of paint left. It's just that they needed a little bit more paint, so they had to buy a whole container of paint. That's the same thing here. You have to buy a whole container to cover that 0.6 that you're missing. So that is why it's 4. And we're done with the review, and I will upload this to YouTube. Have a wonderful day.